as long as the number inside the radical is a perfect square, or has a perfect square, then it can reduce it. Otherwise, it's just going to turn it into a decimal.
Yeah.
All right, guys, so I have a feeling 7.1 was nice. Y'all wasn't too bad with inverse and direct variation and using inverse variation. Well, the rest of this chapter, we're going to be talking about rational functions. So an irrational expression is a fraction whose numerator and denominator are non-zero polynomials. That means that the numerator and denominator, or really denominator for most of these here, will have a variable of some kind. Welcome. We'll have a variable in them of some kind. Now, for some, it might simplify all the way down. There's a few of them that do that. But the domain of a rational expression excludes values that make the denominator be 0. We can't have the denominator of a rational expression be 0. We can't divide by 0. A rational expression is in simplest form when the numerator and denominator have no common factors other than positive or negative 1. Other than positive or negative 1. Because if they have a greatest common factor of 1, it doesn't mean anything. It doesn't really change it. So we need to remove anything that's in common on top and bottom that's other than 1 or negative 1. And that's what we're going to look at first, simplifying these here. So simplifying a rational expression, let A, B, and C be expressions with B different from 0 and C different from 0. We're just saying that because B and C are in the bottom of the fraction. They can't be 0. They could be any other number we want. So if we looked at the first one here, AC over BC, well, since they have C in common, we can cancel it out, leaving us with A over B. And that's it. Or if we have a number in common, so 15 and 65, well, they both have a greatest common factor of 5. We can simplify it out and get 3/13. I've done that before, simplifying fractions. We can do it with expressions. Since they both have an x plus 3 on top and bottom, we can cancel it out, leaving us with 4 over x plus 3. We're just simplifying top and bottom. So, when we look at this first example here, 4 over the quantity x times x plus 2. And we want to simplify anything that's in common on top and bottom. So what's in common on top and bottom? So we do have a 2 inside the x plus 2, but unfortunately, we have to consider this as a single term because of the addition. So is there actually anything in common on top and bottom? No. This one here is actually simplified. That's as simplified as it gets. It doesn't have anything in common. Because if there had been a 2 in front of the x out here, then we could have simplified the 4 over 2 and gone from there. Because of the plus, the x plus 2, those are stuck together. We can't just break them apart. So this is actually simplified. There's nothing more we can do with it. That is simplified as it gets. Because, again, the greatest common factor on top and bottom is 1, so we're done. Let's look at this one here. Is there something in common on top and bottom? X plus 1. There's an x plus 1 on top and bottom. So we're able to simplify that out. And part of the reason that we're doing this here, because you can go on and cross it out, the reason that this works is that we can essentially think of it as undoing multiplication. Because when we multiply something, we multiply straight across. So I could think of this one here as 2 over x plus 3. And just pulling the x plus 1 away from it, because 2 times x plus 1 is our 2 times the quantity x plus 1. The same with the denominator, x plus 1 times x plus 3. I've just rewritten it from here to here. Are we good with seeing how that kind of split apart? Yes? And over here, we have x plus 1 times x plus 1, or x plus 1 divided by x plus 1, which will be 1, leaving us with this here. That's why we can just cross these out. Unlike with addition, because even with the denominator x plus 2, I can't just split it up as x and 2 because of that addition. Does that make sense how this works? Because multiplication, it works fine. Addition, we can't just split it apart. Now, before we move on, we do have restrictions. For this first part, they're not going to specifically talk about it too much. They are very helpful, especially when we come to solving, when we start solving. Because if we have the restriction listed at the beginning with solving, I will sometimes forget to list them at the beginning. It helps us see which solutions won't work, or are going to be what we call extraneous solutions. So here, the denominator can't be 0. So what would make x plus 1 be 0? So x plus 1, we can't have it be 0. So x cannot be -1, because -1 plus 1 is 0. We can talk about the same thing with x plus 3. So since in the bottom of the fraction it can't be 0, we can set it equal to 0 to c. So x cannot be, or this is if we're asked for restrictions. So if we're asked for the restrictions, what values of x can we not have? Because if x, especially for the beginning one, was -1 or -3, it would cause the denominator to be 0, because we have that multiplication. So we can't have -1 or -3. Now, for the most part, the book and some places won't have you list -3. Because in our final answer, we have x plus 3 is still in the denominator, still there. So some say that we don't have to list it. Because it's still there, we can still see it in the problem, that we have x plus 3 in the bottom. If x is -3, it'll still make it be 0. Now they say that we list the fact that x is not equal to -1 because our x plus 1 that was in the denominator, in our final answer, it's not there anymore, so we need to list it to say, okay, this is still a restriction. Even though it's simplified to 1, we still have to list it. Does that make sense? I'm of the notion that, no, I want to list all the restrictions, even if they are still contained in my final expression or final answer. I still want to put them down because they're still restrictions, even if they're still visible here in the function. So let's look at this one here, because for the most part, I feel at this point here, doing what we just did in the last one, y'all are comfortable with. You can see if they're in common on top and bottom, we can cross them out and move on. But here, at this point, I can't just cross out the x squareds because of the negatives, our addition, subtraction signs. They are holding those together. But in our last chapter, we talked about factoring, rewriting it as two sets of parentheses, or two things being multiplied together. And whenever we start factoring these here and working these through, my biggest suggestion is going to be to start with the 1. Here we only have 2, and we start doing multiplication and division, and some of those will have more than 1. I say start with the 1 that you can factor the easiest and go from there. So which one do y'all see is going to be easier to factor? X squared minus 4 or x squared minus 4x minus 12? X squared minus 4 is a what? A difference of perfect squares, yes? X squared, x times x gives us x squared is perfect square. 4 is what? 2 and 2, yes? So the denominator will factor 2, x plus 2, and x minus 2, yes? Okay. Now it seems weird that we'll start with one that's easier to factor because, well, easier factor, why not start with the easier one? But the main thing and the main reason I say that is if we're going to simplify this in some way, we need what's on top, in the two sets of parentheses, to be same as what's on bottom, yes? So I should expect one of those sets of parentheses to be what? Either x plus 2 or x minus 2. I need it to be one or the other, yes? If I start with what I see as easier to factor, it's giving me hints as to what one of those two sets of parentheses on top should be. Y'all see that there. And especially when we start getting bigger ones and starting working with multiplication of two things or dividing, Having those hints is helpful because it'll help us solve the others or factor the others faster. Now, if we factor the numerator, well, there is no greatest common factor, so that's kind of nice. If we look at the third term, 12, it's negative, so our signs are opposite. One's going to be positive, one's going to be negative. Now we look at the factors of x squared. Well, the only factors of x squared are x and x. The other one, we need to find the factors of 12. 1 and 12, 2 and 6, and 3 and 4. Which one of these three sets of factors is probably going to be the ones we need? 2 and 6, because if we have 2 and 6, it will match up with one of the ones in the denominator. Now, do we need the 2 to be positive or negative? And the 6 is negative, because we need that middle term to be negative. So most likely this is going to be the setup. Now, for these here, we can check it off to the side. X times negative 6 is negative 6x. 2 times x is plus 2x, which would indeed give us negative 4x. So this is the correct factors for the numerator. Now, do we have something in common on top and bottom? We have the x plus 2 over x plus 2, yes? Because they are being multiplied, these will simplify to 1, leaving us with x minus 6 over x minus 2. Now, it just asked us to simplify. It didn't specifically ask for restrictions, but might as well go on and do them. They're not that bad. Because when we talk about restrictions, we're just saying what value can x not be. And we always look where we're going to have a denominator, a division of 0. And because x equals 2, because 2 minus 2 is 0, yes? X minus 2 is equal to 0, so we can add 2 to both sides, giving us x is equal to 2. So that's one value that doesn't work. Our other one is x plus 2, yes? Set it equal to 0, minus 2 from both sides, so x cannot be negative 2. So x cannot be positive or negative 2, because if it's one of those two values, we will get a denominator of 0. Questions on this here? Is it possible to have no restrictions? Well, yes. If the denominator does not have a solution, or I, so the ones that we had that didn't cross the x-axis, then we wouldn't have a restriction, because there's no way to make it be 0. All right. Let's look at the next one. X squared minus x minus 12 over x squared minus 9. Which one do we want to factor first? X squared minus 9. How would that factor? X plus 3 times x minus 3, because again, it's a difference of perfect squares. So x squared would be x and x, 9 would be 3 and 3, and the signs are opposite. I have a feeling by this point that y'all like factoring the difference of perfect squares, as long as the numbers are easily to see what they are. It's not that bad. The numerator x squared minus x minus 12, there is no greatest common factor. So we do 2 sets of parentheses. Since the third term is negative, our signs are opposite. One's positive, one's negative. Factors of x squared are x and x. Well, factors of 12 are 1 and 12, 2 and 6, and 3 and 4. Which one do we want? 3 and 4. Which one's positive? Which one's negative? Yep. And if we check this, x times negative 4 is negative 4x. 3 times x is plus 3x, which gives us negative x, which is the middle term we wanted, yes? Any questions on this so far? Now, luckily with this setup, we do have something in common on top and bottom, yes? So these will cancel out. They simplify to 1, multiplication of 1, which just tells us that we have x minus 4 over x minus 3. Yes. Mm-hmm. Mm-hmm. So here x would equal, or cannot equal, because we can set x plus 3 equal to 0. Minus 3 from both sides tells us that x cannot be negative 3. And with the other denominator, our x minus 3. Because if we had an x value of positive or negative 3, it would make the denominator be 0, so it doesn't work. Mm-hmm. Yes. Questions on this here? Now this one here is kind of nice because the numerator is already in simplified form. It's already simplified as it gets. Part of the reason we can tell that is 1, there's only 2 terms. There's x plus 4. We have x and 4. What is the degree of the numerator? What is the biggest exponent in the numerator attached to a variable? 1, because it's the one attached to the x. It's not written. So the degree is 1. If the degree is 1 or 0, there is no variable. It's in simplified form. We can't simplify it any further. The denominator, however, is a degree of 2. We have x squared. So most likely it will factor. Now, I'm going to pause before I say that because there's one stipulation I will say. If the degree is 1 or 0, it won't factor in terms of parentheses, but there still could be a greatest common factor. Because if it was 4x plus 16, greatest common factor of 4, we can pull it out. Now the denominator is hopefully becoming probably one of y'all's more enjoyable ones to do. Because we have x squared minus 16. It is a difference of perfect squares. So we'll have x and x, plus and minus, and 16 would be 4 and 4. Now we do have something in common on top and bottom, yes? The x plus 4 and x plus 4. So they cancel out, so the denominator is x minus 4, yes? What is the numerator? 1. Mm-hmm. With any of these here, whenever something simplifies out completely, greatest common factor on top and bottom simplifies out completely, it's going to simplify to 1. There's no way that we can multiply 2 things or divide 2 things and get 0, unless one of those 2 is 0 already. Because if we're dividing 2 things that are the same thing or simplifying out, it simplifies to 1. We've very much gotten in the habit of saying they cancel out, thinking 0. No, they're simplifying to 1 when we do this here. And here, x cannot be. We can look at x plus 4 is equal to 0. So we minus 4. So x cannot be negative 4. When x minus 4 is equal to 0, add 4 to both sides, so x cannot be 4. So we could say x is not equal to plus or minus 4, or x is not equal to negative 4 or 4. Either one of these work. Questions on this here? Questions on anything so far? Are you good with everything so far? Yes? Okay. Let's look at one more of these here. Because up to this point, really, All we've had are some pretty nice ones for the denominator. X squared differs perfect squares. This one's the first one where we don't have that. So we have x squared minus 2x minus 3 on top, and we have x squared minus x minus 6 on bottom. So this one here, we just need to pick. Do we want to factor the numerator first or denominator first? Denominator. X squared minus x minus 6. Is there a greatest common factor? No. So we can do 2 sets of parentheses with 3 spaces, or just 2 sets of parentheses, especially if you've gotten comfortable with the overall spacing. We can look at the signs. Since the third term, the 6 is negative, our signs are opposite. One's going to be positive, one's going to be negative. Factors of x squared are x and x. Now the factors of 6 are 1 and 6 or 2 and 3. Which one do we want to try first? 2 and 3. Which one's positive? Which one's negative? And again, off to the side, we can check this here. X times negative 3 is negative 3x. 2 times x is plus 2x, which indeed does give us a negative x. Okay. So those are the correct set of factors. Now we can factor the numerator. Now there is no greatest common factor, so we can do our 2 sets of parentheses. Since the 3 is negative, our signs are opposite. One's positive, one's negative. Only factors of x squared are x and x, yes? What are the factors of 3? 1 and 3. We only have one set, yes? So if we're going to have something in common, can the 3 be with the plus? Can we have x plus 3? Goes here. Can I put the 3 here and have something in common? No. And if we're going to have something in common, the 3 has to go with the negative, yes? That's what's nice about this here, is because once we get one of them factored correctly, it kind of gives us a roadmap of what we need on top. Now we can still check this here and make sure x times negative 3 is negative 3x. 1 times x is plus x, which does indeed give us negative 2x, so we do have it factored correctly. So what we have in common on top and bottom is the x minus 3, which leaves us with x plus 1 over x plus 2. Questions on this here? So what would our restrictions be? Yes. Because I think at this point we feel pretty comfortable with x plus 2, the opposite sign, because x plus 2, negative 2 plus 2 is 0. X minus 3, well, 3 minus 3 is 0. So our restrictions are negative 2 and 3. And that there would be our simplified version of this answer. Questions on this here? Questions on anything we've done so far? And again, this is kind of why we went back over factoring, because factoring is a big part of this chapter. Now we will do a few more with multiplying and start bringing those in. So multiplying monomial rational expressions, monomial one term. But before we do that, I want to look at the graph. So the one that we finished with was x plus 1 over x plus 2. That's what we finished with, yes? Now the restriction of x is not equal to 3 is not going to show up. But if we look at this graph, we do have this here. And if you notice, there is a distinct spot where the graphs kind of go in opposite directions. And funny enough, that is at one of our restrictions, x is equal to negative 2. Because that is negative 2 on the graph. Unfortunately, I can't. There are ways to switch it from y to x. But if we look at the table, at -2 we get an error. It is considered an asymptote. There are no values for this function at -2. It doesn't work. And that's kind of why we're having these restrictions, because if we have the restrictions, we know where they won't cross. And they become more helpful, especially if we start talking about inequalities. Using these with inequalities, we know where we can check solutions. Multiplying rational expressions. Let A, B, C, and D be expressions where B and D are different from 0. When we multiply two fractions, we multiply numerators with numerators, denominators with denominators. We multiply straight across. And then if there's something in common, we simplify. So this example here, we multiply and then simplify. And then go from there. So the first one we have is this here. We want to find the product of 8x cubed y divided by 2xy squared times 7x to the fourth y to the third divided by 4y. There's many different ways we could go about doing this here. One of them is breaking them down to their simplest terms. So taking this here, so I'm going to write this first one out. You don't have to write it down. Personally, I don't like it. I find it tedious. Is we can break it down into simplest terms. Because 8, if we broke it down into the prime factorization, is 2 times 2 times 2 cubed. 2 times 2 times 2. X to the third is, well, x times x times x. Y. In the denominator, we have 2x, and then we have y squared, so y times y, times, well, 7 is prime. Then we have x to the fourth, which would be 3, 4x's, y cubed, so we'd have 1, 2, 3 y's over 4y. If we broke it down into prime factorization, broke it down in simplest forms. Then we can multiply them together. So we have 2 times 2 times 2 times 7. We have 1, 2, 3 x's from the first, 1, 2, 3, 4 from the second, 1 y from the first, 3 y's from the second. In the denominator, well, we have 2. Actually, this should have been not 4, because 4 is actually 2 times 2, which would mean we'd have 1, 2 from the first, and then 2 from the second, 1x from the first, no y's, x's from the second, 2 y's from the first, 1 y from the second. Yep. Because what they're wanting to get at is this here. Because anything divided by itself is 1, yes? So I can come through and say, well, that 2 and that 2 simplify out. This 2 and this 2 simplify out. And this 2 and that 2 simplify out. This 1x simplifies with this 1x. These 3y's simplify with these 3y's. And what we have left, we put down. So numbers-wise, well, we only have a 7 left on top, yes? Well, we actually have nothing left in the denominator. So it's going to be 1. The numerator, we've got 1, 2, 3, 4, 5, 6 x's, so that's x to the 6, and we have 1 y. So that simplifies the 7x to the 6 y. I find this very tedious and very, tedious I think is the best word for it, because it's really taking the time to split this out and break it all the way down. We can multiply this together. Multiply like terms. So on top we have 8 times 7. I mean, we can leave it as 8 times 7. That's not bad. We can write it as 56. Let's do that. Because 8 times 7 is 56, yes?
The denominator, 2 times 4 is?
8. Well, hey, 2 times 4 is 8, yes? 8 on top, that 8 will cancel. We could go on and cancel it there. Or we can do 56 over 8. We'll simplify it eventually. Top, x to the third times x to the fourth. When we multiply like bases, we add the exponents. So we have x to the seventh. Y times y to the third would be y to the fourth. We're used to doing this, yes? The denominator, we only have x in one of them, so we only have one x. Y squared times y is y to the third, yes? Questions on anything we've done so far? $56 over 8 is, so we have 7. Now we could still put the fraction bar just in case we do have something in the denominator, because those simplified. If we have like bases dividing, well, like bases, when we multiplied, we added the exponents, yes? So what do you think we would do when we divide? We would not add, but subtract. Because here, x to the seventh over x, we can subtract 1 from 7, yes? 7 minus 1 is what? 6, yes? Did it have more x's on top or more x's on bottom? So it stays on top. So really, we can subtract the exponents from the like bases. Whichever one has the most is where it stays. So if it had been x to the seventh on bottom, it would have stayed on bottom. Does that make sense? Y to the fourth over y to the third. 4 minus 3 is? Or is it bigger on? So do we have anything left in the denominator? No. So the only thing really left in the denominator is 1. We don't have to write over 1. So we have this here, yes? And normally what do we do with our answer? We circle it, yes? So you could erase that division bar if you want. Yeah. Or you can just kind of put it as part of the circle, the answer. But that's it. Questions on this here? Does this kind of make sense? We're used to doing this. But there's different ways to go about it, simplifying. So are we good with this problem here? Yes? We feel good with this? I'm going to show you one other way we could do it. And again, pick which one you like best. Because if we look at this here, because eventually they're going to be multiplied together, yes? Well, this y can cancel out with that y there, yes? These will cancel out with 2 of those. One of those will cancel out with that, the 2 and 4, 7. Because I can just start simplifying there. Anything over the top of itself that has like terms, we can cancel out. So if you see them, I mean, we can go through and just start chopping the thing up and simplifying as we go. But sometimes it's easier to multiply through. Because here, we do have some like terms, yes? 6 and 3 do, 9 and 3 do. So we could simplify there. Or we can go on and just multiply them out first. Because 6 times 9 is 54. On bottom, 3 times 2 is 6. The numerators, we can do the x's. So we have x squared times x to the fifth, which would be x to the 7. I have 2 of them in the first, 5 of them in the second. So how many do we have total? 7. Y times y squared is y to the third. The denominator, we have 1x in the first. We don't have any in the second, so we will just have mx. We have y to the third times y, which will be y to the
4th. Questions on this so far? Mhm. So we have 9 on top, yes? Because 54 over 6 is 9. Since it doesn't have a denominator, it goes in the numerator. Because really what we're saying is 6 goes into 54 how many times? 9. So that becomes 9. The 6 becomes 1. Because we essentially factored 6 out of both, and it canceled. X to the 7th over x to the 1st. 7 minus 1 is 6. Bigger on top stays on top. Essentially, we took 1 away from top and bottom. Leaves us with 6 on top, none on bottom. Last one, we have y to the 3rd and y to the 4th. 4 minus 3 is? Where was it bigger, on top or bottom? So it stays on bottom. And that's it here. Now we can still have restrictions. We didn't do it the last one. We're essentially for these here. It's just that x cannot be 0, y cannot be 0. Because there's nothing added or subtraction. When it's just multiplication, they just can't be 0. Questions on any of this here? We'll do one more, and then we'll leave the rest of this for tomorrow. Man, I keep forgetting I've got to really readjust these slides. They're getting so grainy. So we can multiply 6 times 3 is 18. Wait a minute. No, let's save this till tomorrow. We're out of time.